discussing the first chapter of 10th ICSE Physics, that is chapter force. For convenience, I am dividing the portions of chapter into 5 classes. In the first class, that is in today's class, I will be discussing force, type of force, torque, unit of torque, clockwise and anti-clockwise moment. In class 2, we will be discussing example of torque, couple, moment of couple and equilibrium of bodies. In class 3, we will be discussing principle of moment and some problems related to it. In class 4, we will be discussing center of gravity. In class 5, we will be discussing uniform circular motion. Once again, today's topic, types of motion, moment of force, unit of moment of force, clockwise and anti-clockwise moment. This is the first page of chapter force. The portion mentioned in this page are two kinds of motion of rigid bodies on application of force. The first one linear motion, second one rotational motion. The first one linear motion is also known as translational motion. First case, as we apply a force on a stationary rigid body and the body is free to move, what will happen? It will move in a straight path in the direction of force. As it moves in a straight path, it is known as linear motion or translational motion. Example, a ball is lying on the ground. We are applying a force on the ball. What will happen? It will move in a straight path in the direction of force. This kind of motion is known as linear motion. The second one, rotational motion. So in first case, the body was free to move. In second case, the body is pivoted at a point. So as we apply a force on a pivoted body, what will happen? It will rotate about that pivoted point. So this kind of motion is known as rotational motion. Example, in the case of a wheel, the wheel is pivoted at this point. We are applying a force on the rim of the wheel. What will happen? The wheel will rotate about this pivoted point. So let's discuss the portions in detail. We can go on to the further slide. Okay. So what are the types of motion of rigid body on application of force? The first one, translational motion or linear motion. The second one, rotational motion. Okay. In this slide, the difference between translational motion and rotational motion is given. The first type, the translational motion. We are applying a force on a stationary rigid body. What's the condition? The body is free to move. What will happen? The body will move in a straight path in the direction of force. This type of motion is known as translational motion. In second type, that is rotational motion. Here also we are applying a force on a stationary rigid body. What's the difference? The body is pivoted at a point. First case, the body was free to move. Second case, the body was pivoted at a point. What will happen? The body starts to rotate about that pivoted point. And this type of motion is known as rotational motion. So once again, the difference is that in translational motion, we are applying force on a body which was free to move. In rotational motion, we are applying a force on a body which was pivoted at a point. In first case, it will move in a straight path. In second case, it will rotate about that point. The first type of motion is known as translational motion. The second type of motion is known as rotational motion. Example is given. In first case, ball lying on ground. We are applying a force and the ball is free. What will happen? It will move in a straight path. Second example, wheel. The wheel is pivoted at a point. As we apply a force, what will happen? The wheel will rotate about that pivoted point. Okay. So once again, when we apply a force on a body which is free to move, it will move in a straight path in the direction of force. It is known as translational motion or linear motion. Second case, we are applying a force on a pivoted body. What will happen? It will rotate about that pivoted point. This type of motion is known as rotational motion. Okay. The questions that come from this portion is state the condition on applying a force, the body execute translational motion and rotational motion. So when will a body execute translational motion? The body is free to move, it will execute translational motion. That's the condition, free to move. When will the body execute rotational motion? When the body is pivoted at a point, it will execute rotational motion. Okay? Free to move, it will execute translational motion. Pivoted at a point, it will execute rotational motion. Okay? This is the second page of chapter 4. The topic mentioned in this page are what is moment of force, factors affecting turning of a body, measurement of moment of force, unit of moment of force, clockwise and anti-clockwise moment. Let's discuss each portion in detail. So, next topic is what is torque or what is moment of force. Both torque as well as moment of force, both are same. So we have a body and the body is pivoted at the center. We are applying a force on the body. What will happen? As it is pivoted, this force will cause the body to rotate. This turning effect produced by this force on the body is called torque or moment of force. That is how much this applied force rotate the body. That measurement is known as moment of force or torque, and it is represented by letter tau. The torque is represented by letter tau and is a vector quantity. Okay. Now we know what is moment of force. Next, what is magnitude of moment of force? For that, consider a body that is pivoted at point O. That is at this point. We are applying a force F on that body. What will happen? As the body is pivoted, it will rotate about the point O. Now, what are the factors affecting the turning of the body? First one, magnitude of force. That is how much force we apply. That is 10 Newton, 20 Newton, like that, magnitude of force. Second one, perpendicular distance of line of action of force with axis of rotation. That is, O is the axis of rotation. By extending the force F, we get the line of action of force. That is this FP. So the perpendicular distance between axis of rotation and the line of action of force is OP. So it depends upon two factors, the magnitude of force as well as the perpendicular distance between line of action of force and the axis of rotation. So moment of force is equal to force into perpendicular distance of line of action of force with axis of rotation. This is an important note. We know that moment of force or torque is equal to force into perpendicular distance of line of action of force with axis of rotation. We know that moment of force or torque is same as turning effect of the body. So for increasing the turning effect of the body, we can either increase force or we can either increase the perpendicular distance. But if the force is fixed, how we can increase the moment of force? By increasing the perpendicular distance of line of action of force with axis of rotation. That is written here. For a given force, the force is given. How we can increase the moment of force or how we can increase the turning effect of the body? By increasing the perpendicular distance of line of action of force with axis of rotation. Okay. Next, what is unit of moment of force? We are defining unit of moment of force in two units, that is SI unit as well as CGS unit. We know that moment of force is equal to force into perpendicular distance. That is unit of force is Newton and unit of distance is meter. So unit of torque or unit of moment of force is equal to unit of force into unit of distance. That is Newton into meter, Newton meter. Now in CGS unit, unit of force is dyne, unit of distance is centimeter. So unit of torque is equal to dyne into centimeter, dyne centimeter. Now we are converting Newton meter into dyne centimeter. For that, 1 Newton equal to 10 raised to 7 dyne. 1 meter equal to 100 centimeter. So 1 Newton meter, we have to convert it into dyne centimeter. So 1 Newton equal to 10 raised to 7 dyne. So 10 raised to 7 into how much we 1 meter is equal to 100 centimeter into 100. That is, it is 10 raised to 9 centimeter. Okay. Now, this is a question from this portion, that is, define what is moment of force and state the SI unit. We know that moment of force is equal to product of magnitude of force into perpendicular distance of line of action of force with axis of rotation. Now, the SI unit is asked here. We know that SI unit is equal to Newton meter. If the CGS unit is asked here, the CGS unit is equal to dyne centimeter. Okay. Another question is, state whether the moment of force is a scalar or vector quantity. We know that moment of force is a vector quantity. It's the 1 mark question. State the two factors affecting the turning effect of the force. The two factors we know already. They are magnitude of the force as well as the perpendicular distance of line of action of force with axis of rotation. The next page of chapter 4, the portions discussed in this page are the clockwise and anti-clockwise moment, factors on which direction of rotation of body depends. So let's discuss these portions in detail. So, what is clockwise and anti-clockwise moment? We know that if the body is pivoted at a point, we are applying a force on the body, it will make the body rotate. It can either make the body rotate clockwise or anti-clockwise. So, if the effect of force on the body is to turn it anti-clockwise, that is opposite to the direction of rotation of clock, it is known as anti-clockwise moment and it is taken as positive. If the effect of force on the body is to turn it clockwise, that is to turn it in the direction of rotation of clock, it is known as clockwise moment and it is taken as negative. So, the effect of force on the body is to rotate it anti-clockwise. The moment of force is known as anti-clockwise moment. If the effect of force on the body is to rotate it clockwise, the moment of force is known as clockwise moment. The anti-clockwise moment is taken as positive and clockwise moment is taken as negative. So, next is, what are the factors on which direction of rotation of a pivoted body depends? We know that if a body is pivoted at a point and we are applying a force on that body, it can turn the body either clockwise or anti-clockwise. So, what are the factors that determine this? The two factors that determine this are point of application of force and direction of application of force. So let's discuss this in detail. We know that direction of rotation of body depend upon two factors. That is, first factor is point of application of force and second one is direction of force. So first here we are checking whether direction of rotation of body changes by changing the point of application of force by keeping the direction of force a constant. For that we are considering a disk that is pivoted at the center. So in first case, we are applying force at point A. In second case, we are changing the point of application of force. That is, now we are applying force at point B. In both cases, the direction of force is from left to right. That is, the arrow is pointed from left to right in both cases. So, as we apply force at point A, in first case, the body rotates anti-clockwise direction. In second case, as we apply force at point B, the body rotates in clockwise direction. So we understood that by changing the point of application of force, the direction of rotation of body changes. Let's check whether the direction of rotation of body depend upon direction of force. For that, we change the direction of force on the free end of a pivoted axis. There are two cases, case 1 and case 2. In both cases, that is in case 1 and case 2, we are applying force on the same point. That is point A. We are not changing the point of application of force. Both cases, we are applying force on the same point. But the difference is that we change the direction of application of force. In case 1, we are applying force from bottom to top so that it produces anti-clockwise moment. In case 2, we are applying force from top to bottom. So it produces clockwise moment. From this, it is clear that by changing the direction of force, we can change the direction of rotation of body. The next question is, when does a body rotate? And state one way to change the direction of rotation of body. Give a suitable example to explain your answer. So first question is, when does a body rotate? When does a body rotate? When the body is pivoted at a point and we apply a force on it, it's rotate. Okay, when a force is applied on the body which is pivoted at a point, it rotates about the pivoted point. The answer. State one way to change the direction of rotation of body. We have discussed earlier the two ways to change the direction of rotation of body. That is by changing the direction of force, by changing the point of application of force. Here one way is only asked. So we can say by changing the point of application of force, we can change the direction of rotation of body. Here the example is given, is already discussed in the previous slide. So go through it. Write the expression for moment of force about a given axis. We know that moment of force is equal to force into perpendicular distance of force from the axis of rotation. Next, what do you understand by clockwise and anti-clockwise moment of force? When is it taken positive? We have already discussed that when the effect of force on the body is to turn it anti-clockwise, the moment of force is called anti-clockwise moment and it is taken as positive. If the effect of force on the body is to turn it clockwise, the moment of force is called clockwise moment and it is taken as negative. State one way to reduce the moment of force of a given force about the given axis of rotation. We know that moment of force is equal to force into perpendicular distance. So how can we reduce the moment of force? By decreasing the perpendicular distance, we can reduce the moment of force. State one way to obtain a greater moment of force about a given axis of rotation. Here also we know that moment of force is equal to force into perpendicular distance. So to obtain a greater moment of force, what's the easiest method is to increase the perpendicular distance of line of action of force with axis of rotation.